Okay, let's talk about chi-test. So chi-square is the distribution of sum of xi square, where x is the normal distribution. The purpose of chi-test is to determine association of categorical data. We can look at two examples and two main usage of such a test. One is the goodness of fit. It's pretty much calculating the observation minus x total number of the observation multiplied by probability, meaning like your expected. Those two together will be expected observation, as it was following the probabilistic distribution that you assumed on your null hypothesis. For instance, this one we just try to assume try to observe if the die is a fair die. Of course, if it toss 60 times, of course the expected number of rolling any number will be 10 divided, so pretty much 60 divided by 6. And then here is a row of observations. Those will be OI, and the expected for each one are the same, which is EI equals NPI. So you can sum all together. Degrees of freedom is a category -1, which is 5. There are 5 categories. So that's one way. It's Pearson's chi-square test. Another application is the time of independence. Pretty much try the null hypothesis as variable 1 is independent of variable 2. So the chi-square will be pretty much observation of I under the condition J, and then expected expectation if they are independent. So for instance, this is pretty much testing if male or female have the preference of tea or coffee are independent of you being male or female. So with this, we can just sum over tea or coffee for either of both genders. Then you will know that if they are independent male or female, there will be 60 divided by 140, with the probability of a person prefer coffee, multiplied by the total male or female, which both are 70. So this is expected of male liking coffee, female liking coffee. Similarly for tea, you got 80 divided by 140 multiplied by 70. And we can, based on this, is expected, and then observation are those. So it's by plugging it in all those 4 elements in the matrix into OIJ and EIJ, it's quite trivial to calculate its chi-square. We know that the degrees of freedom will be the row 1, total row of 1 minus a total row minus 1 multiplied by total column -1. So for this case, it'll be 2 minus 1 multiplied by 2 minus 1, which is 1. I'm going to just check the chi-square in the table. And here is what it looks like as a chi-square with different degrees of freedom of 1, 3, 5, and 20. As you can see here, and I have a video on calculating chi-square distribution. I'll try to remember to put a link in the description.